Okay, now in this video, I'm going to review how to solve a 3x3 linear system of equations using the addition/elimination method. So step one in solving any of these 3x3 systems is to take the 3x3 system and reduce it to a 2x2 system. And to do that, I'm going to use elimination. So I'm going to pick any pair of equations up here and eliminate one of the variables. I'll take equations 1 and 2, and I'll eliminate x. And I can eliminate that x if I multiply everything in equation 2 by -1 and then add the equations together. Okay, so I'm not going to do anything to equation 1. I will now multiply equation 2 by -1. And now the coefficients on the x variables are opposites of one another, so when I add the two equations together, the x variable is eliminated. All right. 1x plus minus 1x is 0 x's. 1y plus -2y would be minus 1y. 1z plus 3z would be 4z. And 0 plus -5 is -5. Let me take this equation and put it off to the side over here. Minus y plus 4z equals -5. And now I'm going to pick any other pair of equations and eliminate x again. So I'm going to take equation 1 and equation 3, and I'll eliminate x. And to do that, I'll multiply everything in equation 1 by -3. Okay, so let me multiply everything in equation 1 by -3. So I have a minus 3x minus 3y minus 3z equals 0. And now let me add the new equation 1 and equation 3 together. And since the coefficients on the x variable are opposites of one another, when I add them together, the x variable will be eliminated. All right. Minus 3x plus 3x is 0x. Minus 3y plus 4y is a 1y. And minus 3z plus 2z would be a minus 1z. And 0 plus a -1 is -1. So now I'll take this equation and I'll solve this 2x2 linear system. Right? I've accomplished what I wanted. I wanted to take the 3x3 system and reduce it to a 2x2 system. Now I can solve this, and in fact it's already set up to be solved using the addition/elimination method. The coefficient on the y variables are opposites of one another. When I add the two equations together, the y variable will be eliminated. Minus y plus 1y is 0y's. 4z plus a minus z would be 3z. And -5 plus -1 is -6. And I can solve this for z now. 3z equals -6, so z equals -2. Now remember, the solution to a 2x2 system is a value for both variables that satisfy each equation. So I've already found the value for z. Now I'll have to find the value for y. To do that, I can take z equals -2 and plug it into either one of these equations and solve for y. I'll do it right here. I'm going to take z equals -2 and plug it in right here into this equation and solve for y. When I do that, I get y minus z, but z is -2, is equal to -1. Y plus 2 equals -1. Y equals -3. Okay, so I found the value for z, I found the value for y, and now I have to find the value for x, right? We were out to solve this system of 3 equations and 3 unknowns. I know what z is, I know what y is. To find out what x is, I'll take those values for z and y and plug them into any equation up here in the original system. I'm going to plug it into equation 1. That looks like it's the easiest one to do. All right, so equation 1 is x plus y, but y is -3, plus z, but z is -2, and that's equals 0. And so I get x minus 3 minus 2 equals 0. X minus 5 equals 0. X equals 5. So the solution to this 3 by 3 system of equations is an order triple, right? It's a value for x and y and z that satisfy all three equations. And again, if I had time, I'd make sure that these values, when I plug them into each equation, the equations are all satisfied.